Hello everyone. I'm very excited to deep dive into the DevSecOps topics. So today our topic is AWS DevSecOps CI/CD pipeline. So where I have set up one a basic photo sharing app application, and we have set up whole application in our AWS using all the AWS service, all the AWS security services. So currently we will first talk about the infrastructure management with the DevSecOps. So we are using here something called infrastructure code, which is a Terraform, where we have written .tf files, which will create the resources for you, like your EKS cluster, network load balancer, CloudFront, Route 53, AWS WAF, like many resources it will create for you. And for storing the code, we are using the GitHub, and automating tasks, we are using the GitHub actions. And along with that, we are also security scanning in the pipeline. So we are using two tools here, Tfsec and the Checkov. So basically Tfsec is mainly meant for the Terraform. It will like prompt you that like suppose you have created one S3 bucket and the encryption is not enabled, so it will tell you that you should need to enable the server side encryption in the S3 bucket. And along with that, I am using the Checkov as well. So it is a similar to Tfsec, but Checkov checks our Terraform code, and other than that, it also checks the Kubernetes configuration, and it makes sure everything is to set up securely before anything goes live. And apart from that, like we are also focusing on compliance with Checkov. So we also use Checkov to ensure like our setup is compliant with the PCI standard, which are make a very important security standards for the payment data. So Checkov checks our configuration against these standards to avoid any issues, uh, like before we even start building the infrastructure. So let's overview this architecture. Here you can see that here we are using the Route 53, which is manages the domain name for application access. And if we move forward, we have a AWS Cognito, where it will pop up for the user who can access the applications. Then we have ACM certificates, which secure the traffic through encryption. Then we have set up the CloudFront, which is Amazon Content Delivery Network that speed up the images download by caching them in the S3 for the faster access globally. Because it means that like CloudFront stores cache in its edge locations. Then we have set up the AWS WAF, which is protect against the malicious or bot traffic. Here we are using the S3 bucket, like where we are storing the our users images. Then we are using the AWS Macie here, which will scan the S3 bucket to ensure that they do not contain any sensitive data, which will I will explain you in the demo. Then we have set up our network load balancer, so the traffic will go to the EKS via the network load balancer, and we have also implemented the AWS and WAF on top of it, along with the ACM. Then we have a EKS where we have hosted our application code, and we are accessing the secrets by the secret manager, and we have also implemented the system manager. So we are not creating any PEM file for any node. We will take the SSH from the system manager. Now we are deploying the application via the code build. So code commit we are using, so developer will commit the code changes to the Git repository, so like similar to saving the latest version of his work. Then we will trigger the code build. Automatically it will start the build process when the changes are committed. So where we have like in the code build, we have defined the pipeline with the stages. So first of all, we have the git list secrets, which detect the secret information like in your code, like password or the API keys. Then we have implemented the SonarQube, which will scan code for your bugs or the potential issues, which will give you the code coverage. Then we are using the header-lint. Header-lint is used for validating the Docker file for the mistakes or the poor practice. Like suppose we have created one Docker file, and in there we have given the from space the image name, but we are not mentioning any version over there. So that's a poor practice. Then we have a Python application uh, and we have Python app application. Then the tool we have used the Trivy here, which will scan Docker images for the vulnerabilities, and after that, after validating everything, our Docker image will push to the ECR. Then after the code build is done, means after ECR, the code will push to the EKS, and whatever the data is there, it will go to the DynamoDB. After whole this process, if it gets fails or abort or error or success, we will get the notification in the Slack. And apart from that, we are also taking care of the additional security measure. We are using the Kubescape, which will scan the Kubernetes whole cluster. It will test the NSA and the MIST framework. Like it will scan the whole Kubernetes cluster, how many vulnerabilities are there, how many percentage they are compliant with the NSA. We will see in the video. And we have along with that, we have the audit and the governance tool, which is AWS config, AWS CloudTrail. We have Amazon Inspector, and the last not last, we are also using the Prowler. So it is a security scanning tool which is used to check AWS account for the vulnerabilities, which I will show you again in the video. Then in the last, we will do this whole setup with the chaos engineering. So we are using the AWS fault injection service, which is known as the AWS FIS, a managed service which will enable the fault injection experiment based on the chaos engineering principle. Like suppose we have one Kubernetes cluster and we have the 4 node groups. So what we will do, we will stop or terminate the node from there, and then we will see the description of the services from there. Okay, so this is the whole architecture, and let me jump into the demo. So let's start with the infrastructure code, that what we have written over there. So this code is already cloned on my local laptop. So we have created one folder called Terraform-infra. Inside that, we have written all our TF files. So we have so first of all, we have created the one VPC. Inside that, we have the one internet gateway, we have one NAT gateway. Along with that, we have 2 public subnet, 2 private subnet, along with their route tables. Then we are creating the one S3 bucket, where we have used the public Terraform AWS module, where we are encrypting our bucket via the SSE algorithm, which is AES 256. And here we are using the provider. In the provider, we have mentioned the AWS provider, because we are deploying our architecture in AWS. So if you have a Google, then you will use the provider of the Google. Here we have mentioned the region and the account ID where we want to deploy. And the interesting part here, you can see that here we have deployed 2 times provider of AWS, because we are also using the CloudFront. And as you know that if we are using the CloudFront, and if you want to implement the ACM certificate over there, then the ACM should be present on the North Virginia region. So that's why we have used the alias over there. And here we have mentioned all the provider versions. And this is called output.tf file, where we are outputting our node group information, DynamoDB information, S3 VPC details, whatever we are going to create in the architecture, we are getting the information for them. Now we have declared one locals.tf, which we are using in a tag. And here we have a file called EKS.tf, where we have mentioned the required permission. Here we are creating one EKS cluster along with the 2 node groups. And we are mentioning if we talked about the Terraform.tfs, so we are mentioning the cluster name, cluster version. Here we are passing the information from the dev.terraform.tfs. And here we are using the spot instances, and whatever you can change your configuration as per your need. And if we talked about the CloudFront.tf, here we are again using the public Terraform module of the CloudFront, and where we are using the ACM certificates as well. So Along with that, we have backend.tf where we are storing the our Terraform state file. And we have talked earlier in the provider that we are declaring there are two areas here. So one we are creating for the load balancer, and one we are creating for the North Virginia. Okay, so let's move to the demo. So let's go to the GitHub workflows and go to the actions. Sorry, and let's click here and let's click. So let me first explain you the my GitHub action pipeline. So in the GitHub action pipeline, we have given a name called Terraform and security scanning. So by default, we are using the workflow dispatch, and here we are sending the input as a default node. So whenever we push any commit to this branch, our pipeline will not run automatically because we are sending the default as a no. And here we are using the environment, and same thing we have declared the two jobs here. One is called the infrastructure dev, and second is for the infrastructure audit. So in the infrastructure, it will we are using the Terraform init format validate, and we're using the Terraform plan and Terraform apply. And in the audit, we are running the Tfsec and the Checkov. Whatever we have discussed earlier, that we are using like we are running the security scanning in the pipeline. So for that, we are using the Tfsec and the Checkov. So let's go to the actions. Let's click here. Let's pass the parameter called yes. Let me refresh this page. And you can see that whatever we have mentioned in our workflow, that first of all it will do it will check out, then it will perform Terraform init format and validate, then he will run the Terraform plan and Terraform apply. So let's click here, and you can see that Terraform init has been initialized and it's been done. Now the Terraform plan is also done, and you can see that it is showing here the plan, right? Let's wait for to complete this. So the architecture is already deployed, and you can see that no changes you can see over here. And if we go here and if we talked about the Terraform, this is a second pipeline where we are running our Tfsec and the Checkov. So let's move to the Tfsec. So if you can see the Tfsec, that we have a one EKS cluster where we have allowed the cluster from the so we have a public cluster, okay, and we have also access from a public sider 0.0.0. So it is showing you that EKS cluster should not be public. And if you scroll down, you can see that it is also throwing you the error that we should enable the point in time recovery should be enabled on the DynamoDB level. And if you scroll down, you can see that the control plane API logging is not enabled. So whenever we thought about the PCI compliance, these things are very necessary. So we need to enable it over there. And if you click any of the link, you can see all the information here, that how to resolve this and everything. You can see that we were getting the error called that AMS key does not have rotation enabled. So if you want to remove this error, and so this is medium vulnerability. So if you want to want to fix this issue, so we need to enable this variable called enable key rotation is equal to true. After that, you can see that this error will not come. Okay, then let's talk about the second tool, which is our Checkov. Let me scroll down. So Checkov will also scan your Kubernetes configuration file, configuration pipelines. Okay, so if we scroll up, you can see here that so you can see that we have written it's showing you the error memory request should be set. So we have one deployment file. If I go to my code, you can see that we have one deployment file where we haven't mentioned the memory limit and request. So that's why it is showing you that this is not a good practice. You have to should implement in your application YAML file. And also it is also showing you that the default namespace should not be used, right? And definitely this is not a good practice. So if you click here again, same here, you can see that how to fix this. For this we need to declare one variable called namespace as a key, and you don't have to use the default namespace. You have to give your you have to create your own namespace by the command called kubectl create namespace and namespace name, and here you can declare it to fix this issue. Okay, so in this way you can scan your Kubernetes configuration file, and it was also showing this in the CPU limit should be set. So these things you can validate via the Checkov in your for your Kubernetes configuration YAML files. And if you go down, you can see that we Checkov also scans Checkov also scan the Terraform code. Okay, so you can see that here it is giving the error, the ensure VPC flow logging is enabled in all the VPC, but we are not enabling VPC flow logs, right? So suppose you have a case that you don't want to enable the VPC flow logs in your lower environment, that is dev or QA. Okay, so what you can do, if you go to the ecr.tf file, you can see that here I have used one comment like #Checkov skip. So what you can do, you have to add a skip Checkov skip, and the number you can see CKVAW163. So then what you can do, you can copy this, okay, and paste it over here, and whatever ensure VPC flow log enabled, you can give a description. Okay, so when you will write this on your .tf file, and again when you will scan this code, it will not show you this check again. Okay, it means that we have skipped this check, and we know that we will enable this in the production. Okay, so this is all about the infrastructure code scanning. Now moving forward, we will see the demo on this architecture. Like we will see the AWS Codebuild and all the respective tools. So before starting that, let's go to the code, and if you can see here that this is my Flask application. Whatever we like going to run in the demo. So this is the code. Apart from that, we have created one Docker file, where a simple Docker file where we are copying our required files. So let's talk about the Buildspec file. Okay, so whenever we talked about the code build, code commit, so we have to create one buildspec.yml file. So if you see in the buildspec file, you can see that here we have the phases, okay, which is have a install phase, we have a pre-build phase and the build phase and the post-build phase. So same thing in the install side, you can see that here we are installing the git leak, which will help you to detect secrets in the code base. And then we are using we are installing the Trivy here as well, which is installed to scan the Docker images for the vulnerabilities. Then we are installing the Hedolint, which will install to link the Docker files to ensure that they follow the best practice. Then we are installing the kubectl here. Then if we jump into the pre-build command, this command is used to log into the AWS ECR. So it will before pushing the Docker image to the ECR, our Hedolint will run it. We will see in the pipeline. And then in the build command, the same thing, it will git leak secrets in the it will it will see the like in the build command, before installing, it will see that there is no as such secret are present in the file. And same thing it will, and then Trivi will run. Okay, it will ensure that it will scan our Docker image before before pushing to the ECR. Okay, then here we are authenticating our code build with our Kubernetes cluster via the assume role. Okay, so this is the code. So let's jump to the demo. Let's go to the code build project. So here's the project where I have created the project. So if you click on the edit button, so here you have to give your project name. In the primary, you have to choose your provider where you want to do it. So currently you can choose a code commit or GitHub. So our code is in the GitHub. So I have taken over there. And then we have, these are the default properties, you can use it. And the build spec file, which we are talking earlier. So this is the build spec file which we have to choose it. And then we are sending the logs to over the CloudWatch. And this is the role which we are using here. Okay. So let's go here and let's build this. And apart from that, I think code is not updated on my local laptop. If we go to the build spec file, we can see that we are also installing the SonarQube. Okay, and whilst to the SonarQube, we are also running the Sonar scanner. Okay, so let's go to the build. Let's click on the start build. And we will see each and every tool here. And after the tool is done, we will also get the notification in our Slack. Okay, so you can see that Sonar scanner is installing, and then after the installation is done, then it is running the Sonar scanner. So for this Sonar scanner, we are using the SonarQube Cloud here. Okay, Sonar Cloud, we are using it. You can also use the open source as well. So, but both settings are the same. Okay, so how to connect the SonarQube with the application code? You have to go to the administration option. Then you have to go to the general settings, or sorry, you have to go to the analysis method. Okay, then you have to choose like which CI you want to use. Okay, if you are using the GitHub Action, you can use it, or if you're using the Travis, you can. If you click here, it will show you that how you can declare on your Travis CI. Okay, but we have chosen the manually option. If you have a project is a Maven, so you have to declare this property on the pom.xml file. Same for the Gradle, same for the .NET. Okay, but our application is a Python Flask application, so we have chosen the other option, and this command we have replicate over there, and this Sonar token we have created a secret in our GitHub. Okay, so let's go to the GitHub, and this is our code build. As you can see that everything has been I think installed. Okay, so let's as the architecture, you can see that it will first scan our git leak secret. Okay, so let's copy it. And search for the git leak. Okay, so you can see that the binary has been installed. Okay, and you can see that I can see Trivi here. This is a SonarQube report that execution success. Then if we can go, it has run the git our git leak secret. Okay, we will see over here that where it will win. Okay, so okay, so first of all we want to see the gitly secret, so we will see it okay, so here we have find it. So if you can see that the command is running the gitly secret detect hyphen source, you can see that it is has given you information that the no leaks found. Okay, so no leaks found means that if you have any information as like you have exposed any secret over there, okay, then the git leak will identify it, and it will show here as a file name, okay, that in this path this key having the API key. Okay, then our second tool is the Trivy. So the Trivy will scan our Docker image with these vulnerabilities. Okay, let's go down. You can see that the Trivy has scanned our Docker image, and you can see that it's shown as high as a 104, critical as a 5, medium 433, and low as a 523. So you can see in this way you can see all the details via the Trivy. So as you can see right now that you can see that non-privileged session is in the ch root. Okay, so it means that we are using the root user here. Okay, so it is not good practice to use the root user. Okay, so everything you can see it over here, and you can according to the vulnerability you can fix your Docker image. Okay, so moving forward that let's go to the our diagram. You can see that then we have a SonarQube. Okay, so if we go to the overview, and if you can see here, you can see we have the quality. So we have created one quality gate as well. So if you can go here, you can see you can create your own quality gate as well. Okay, whatever the quality gate you're choosing, that quality gate has been applied for you. Okay, so if I go to there, and if we see for the C4 analysis, it will show you the let's go here. You can see the timing over here, it's the latest build. Okay, and you can see that overall code over here, that what are the securities over here. Okay, what is the code coverage, what is maintenance. So let's click over here, and let's understand here. So if we click here, we can see that it is showing you that specify a CPU limit for this container. Okay, so this is shown you the Kubernetes one, and if you go here, you can see that is also showing you that we haven't used the tag here. Okay, so we are using the latest image. We are not using any tag like Slim, or we are not mentioning any version over there. Okay, and apart from that, if we see here, if we go down, okay, so you can see that it will show you the code coverage as per your configuration, that whatever you have defined in your quality gates. Okay, so moving forward that, let's discuss about this one. We already discussed about the Trivy and everything. Then after the scanning our image, our image will push to the ECR. Okay, so let's go to the ECR. And you can see that one image has been pushed. Let's put a latest one. You can see this is the tag which has been came, and already we have enabled the inspector in our account. So you can see that from the AWS ECS service, you can also see the description, severity, and the CV from here as well. Okay, and after the all the checklist done, it will deploy to your EKS cluster. Okay, so let me open it. So I'm using the IDE called K9s, and this is my name. This is my application, my app. And if I describe it, you can see that it is deployed by 83.1. I think this is our tag image only. And if we click here, yeah, so this is our latest image. Okay, so let's start with the demo. So if we go to the K9s, okay, so if we have, okay, before starting showing a demo, so let's go. So now the important part is that how we are authenticating our code build and the Kubernetes cluster. Okay, so for that I have written one small script which will create the IAM role for you, which is the with the trust policy, and it will also update your config map AWS auth in your Kubernetes system. Okay, so let me run this. So you can see that it is already showing you that the role already exists and skipping the creation. And you can see that my EKS Codebuild role is already has been added in our auth config map. So if I show you my Buildspec file, and if I go down, you can see that here we are using the temporary credentials, okay, to authenticate our Kubernetes cluster. Okay, and in the deployment.yml file, so here I'm using the config map to retrieve the bucket name and the CloudFront domain. So in this bucket in this bucket we are storing our image or txt file or anything, and from this URL we will download the image from there. Okay, and this is the simple deployment file where I have written a container specification with the port number. My application is running on the 5000 port number. Then we are creating one service where we have mentioned our port and target port. Port will help you, the kube proxy will open the port on the worker node, which will route traffic to the LB. Okay, and then we have an ingress file where we have mentioned the annotation that which ingress class we are using, which certificate we are using, and here we have mentioned the roles. Okay, so if I click in this here, my in this URL, my application will start working. Okay, so let me copy this. If I click here, you can see the photo sharing application using AWS services. So let's first choose file and choose action.webp, and let's click on the upload photo. So you can see that I have prompted one message that successfully has been uploaded. So let's download this. So before downloading this, let me go to the S3 bucket and show you the exact. So if I click here, you can see that action web p has been successfully uploaded. Okay, in this specific time. Now we will download this. Suppose you have a friend and that he wanted to need this picture. Okay, so need this picture. Okay, so let's go to DynamoDB as well, where we are storing the data. Okay, let's click on the table. Let's click here. Let's explore table items. Okay, and if I see here, you can see here that okay, let's go here. Share webpack, and our file name was .webp. You can see that it will prompt you to download the image, and you can see that the image has been successfully downloaded. So you can see that this is the this is the DynamoDB, where we are storing where we are storing the information, the photo ID as a partition key. Here we are using the CloudFront URL. So I have mentioned the download and the share, and here we are mentioning the file name, and here we are taking the S3 URL. Okay, so this was the small application which I have deployed in the AWS. Now lastly the part is left, which is the our Slack notification. So you can see that our code build has been successfully built up. Okay, and if we go to the last, you can see enjoy the day. Okay, you can see that everything has been succeed, and if you go down, you can see that I have implemented this via the chatbot. Okay, I am using the chatbot here. Like I have integrated the chatbot plus SNS with the code build. So if I go to the code build here, and if you go to the actions, and if you click on the manage notifications, so from here you can manage it. Okay, you have to what notification you wanted: success, failures, success, stop, failure in progress. So you can see that we are getting all the notifications. Succeed one we are getting over here. Okay, succeed means download source, install, pre-build, build, post-build. So if any stage failed, it will give the notification to you. Now we will look into this AWS Macie service. Okay, so let's go to the AWS Macie. Let's go to the so you can see that is the Amazon Macie is a fully managed data security and data privacy service. Okay, which in the behind it is using the like machine learning and pattern algorithm to discover and protect our sensitive data in DWS. Okay, so suppose if we have a one bucket, and inside that bucket we have a IAM keys. Okay, or we have a username password of the RDS. So Macie will automate automates discover the sensitive data at scale, and it will show you that this data is present in this bucket. Okay, and most of the in the use case we are using the Macie, like suppose we have a PII. Okay, or we have financial data. Okay, so it will support the compliance efforts by helping to identify and secure our sensitive data, whatever data is stored in the AWS S3 bucket. So if you click here in the buy bucket, you can see that we have the two buckets. Okay, so if you click here, you can see that Corridor staging UI and the photo app UI. So how many medium vulnerabilities are here? Okay, so everything, the reports you can see here here as well. Okay, and if you go to the summary, you can see that we have a one non-sensitive data. Okay, and if I click here, so you can also run a job here as well. Okay, so suppose if you want to analyze your any bucket, so you have to click on the create job, and you can specify your bucket as well. Okay, and suppose we have this bucket we have, right? So it will give you the whole information that whether it is public accessible or not, or whether all the ACLs are blocked or not. Okay, then we have a different service called Amazon Inspector. Okay, so the Amazon Inspector is an automatic security assessment service which will help the security and compliance of your application deployed on the AWS. So after enabling the Amazon Inspector, if you click here on the by vulnerability, it will also scanning our container images. Okay, so currently I think it is supporting the container images, container repository, lambda function, and the instance. Okay, so if I go to the instance side, okay, and you can see that currently we are running the two EC2 instances, and if I click here, it will show you the information that which are the package vulnerability we have. Okay, if we click here, then we can get the all over the details of the CVE. Okay, and the best part is that we can also run our CIS. Okay, that we can scan our instances to see that if that they are meeting with the our CIS benchmark or not. Okay, so you have to click on the create new scan, and you have to give a name called test, and here you have to give the key and the value. And remember one thing, that we need to attach the SSM manage store and this second permission to the our EC2 node group, and then you can choose the level whatever you want to scan it. Okay, so this is all about the inspector. And one thing, from the dashboard you can see all the information of your ECR repository information, ECR container information, and what are the EC2. Like suppose we have the 2 AMI. Okay, so currently I don't have any lambda, so it will not give you the information regarding the lambda function vulnerability. Okay, so now the I love this service most, CloudTrail, because it will track your user activity and the API usage. Okay, so if I click here, okay, and if I click on the event history, you can see that which user has opened this service. Okay, so you can see that currently I'm logging with the root user, and I was listing down the Macie service. Okay, so from here you can track it. Okay, that suppose you have a team of 10 peoples, and we have a 10 production server, and somehow somebody has deleted the one server from your account. So you can identify that user with the CloudTrail level. If you click on the CloudTrail, you have to search it from the username, so it will show you the all information of your the information of the user, whatever the activity has done it. Okay, so if I click here, if you will click here, you can see that whatever, see, my name has been came, that Ravindra has been like listed the data identifiers in the services. Okay, so it will show you all the events over there. Okay, and whatever I have the access key in the which region I have accessed, so everything you will get it. Okay, now we will go to this, and we will look out our Kubescape tool. Okay, so let's close this terminal. Okay, and let's type the Kubescape. Okay, Kubescape hyphen help command. We will use the Kubescape scan command. So whenever we run the Kubescape command, so Kubescape is a tool like designed for it's a security posture for the Kubernetes cluster. Okay, and it is the open source solution, and it will detect the misconfiguration and the vulnerabilities in your Kubernetes cluster. Okay, so the purpose of this that is that it will scan your Kubernetes cluster against a set of your best practices. Okay, known as the NSA and the CISA Kubernetes hardening guidelines. Okay, and also it will show you the benchmarks like the Mitri and the NSA framework. Okay, the functionality of the Kubescape is like it will scan your Kubernetes cluster, whole Kubernetes cluster, with the YAML files, hem chart, and it will identify the security issues and the misconfiguration. As you can see right now, that after the scanning of a Kubernetes cluster, it has given the full report. Okay, that whatever we have whatever we can see right now, that we can see that audit logs are not enabled. Okay, RBAC is not enabled, SCD encryption is not enabled, so it is giving you a hint that it is enabled over there. Okay, and if we go down, you can see that you can see, if you go down, that you can see that we don't have any network policy implement. What is network policy? Suppose we have two namespace, okay, namespace A, namespace B, and so by default namespace A can ping the power of namespace B, and namespace B can do the vice versa. but but if there is no as needed that both can talk to each other, so we can implement network policy and we can restrict the traffic that A can't should talk to uh, namespace B. Okay, and and also you can see in the last that it will also show you that we can also scan our deployment. So if you copy this command, okay, and if we run it, and you can see here that it will, by default it has uh, given you that this is not that this is like 70%, it is only good EKS cluster, okay, from the NSA framework point. Okay, now we have scan our deployment my app where our application is running. So it will take some few seconds more. And you can see, if we go, you can see that in the workload we have a like host network access, we have not root containers. And so not root container means, like, suppose we have a one deployment file, okay, and inside that it is like a security purpose, okay, that we should not use via the we should not use the root users, okay. And suppose after taking the SSH of the pod as well, we should not able to write any file, okay, that should be a read only file system. Okay, so see, as you can see that we have scanned our deployment file. Okay, so you can see that these are the failed automatic mapping of service account, network policy is missing, privilege escalation, okay, Linux hardening, non-root container, whatever we are talking about earlier. So Kubescape is particularly like useful for organization like which they are utilizing Kubernetes at scale, who need a maintain strict security and compliance. They can use the Kubescape over there. Okay. Now we will talk about the Prowler service. Okay, if you go to my GitHub, and you can see that we have mentioned the Prowler. So Prowler is used for like, it is an open source security tool, okay, which is designed to perform the security assessment and the audits of the AWS account. Okay, mean it will comprehensive checks and ability of the securities. Okay, so I am using the SAS tool over here. Okay, you can use the open source Prowler as well. Okay, so if you click on the overview, you can see that my already scan has been ran. Okay, you can see that how many medium vulnerabilities we have, how many we have low, and how many we have the uh, critical. Okay, so Prowler we conduct, and like Prowler we check our AWS services, okay, based on the securities, best practices, and the hardening guides. Okay, so if these checks are derived from the CI's benchmarks, okay, AWS security best practices. Okay, so let me show you that if I go to the services, if you go down or scroll down, okay, you can see in this my account 502 checks are fails. Okay, and if I click on the services, you can find the vulnerabilities, means it will like scan all your various AWS services, okay, such as IAM, S3, EC2, Inspector, or 53, and resource group. Okay, so if I click on the AWS EC2, you can see that I have enabled the security group, which is having a no security group allow ingress from 002 S22 port. So it means that there should be a no security group which allows the 22 port should be allowed with the 0.0 cider. Okay, and it is also if I click on the compliance one, so it will also offer the specific modules to evaluate your AWS environment regarding the standards like the CIS, HIPAA, PSI, PCI, GDPR. Okay, so if we talked about the if we talk about the AWS well architect framework pillar. Okay, so you can see that our guard duty is not enabled. Okay, so we should enable the guard duty. EBS default encryption is not enabled, so we should like enable the enable the EBS encryption all on all the EC2 instance. VPC flow log should be enabled. Okay, and and if I click here on the cloud one compliance overview, from here you can also see that how like according to the region you can also see that how many things are affected. So use case of the Prowler is very easy, that it will help you the security findings in the, it will help you the compliance assurance. Okay, it will help you the continuous monitoring, and it will also give you the incident response. Okay, so it is a cloud security posture measurement tool. Okay, and you can also download this report as well. Okay, so that whatever we are currently seeing here, if you go to the overview as well, you can download your reports, and after that you can fix the issue. Okay, now we will see our last part, which is our chaos engineering, and that is a very interesting topic. So if we go here, Amazon FIS, and you can see Amazon FIS is a chaos engineering tool. Okay, and where it is a fully managed service. Okay, it is for running the fault injection experiment. Okay, so if you go to your left hand side, we have resilience management and we have a resilience testing. Okay, which will help us to perform the injection experiment on our AWS. Okay, so let's go to the experiment templates. Okay, and if we click on the like experiment template, you can see that it will give you the account targeting. So we will choose our own account, and if we click on the our account side, so the purpose of this like fault injection service is useful to mitigate potential issues. Okay, before they causing the impact to your operations. Okay, and it will test your system handle failures. Okay, and we can simulate different types of failures, including server outage, system overload, API throttling, CPU usage, network latency, and we have the template and the scenarios which we can use it, and we can integrate these services with our AWS services like EC2, EKS, RDS. Okay, ECS as well. Okay, so basically it is a very good use case. If we can perform on this, like it will help in the resilience testing, it can help us in the performance benchmarking, and it will also help us in disaster recovery. Okay, so let's start with this. Let's give a name called photo app. Okay, and if we go to the action, now we have to give a photo app action. Okay, then we have to choose our action. We can performing the thing on the EC2. Then these things you can see that we can stop the server, we can reboot the server, we can terminate the server. So we will terminate our EC2 server. Okay, and let's go here. Now if you go here, you can choose via your resource IDs. Okay, so let's choose this one, our EC2 server. Okay, and let's go to the save. Okay, and you can create your IAM role as well, or you can you can choose a create new role for your experiment template, which will be created by the Amazon FIS. Okay, and you can also create the CloudWatch alarm, and also you can send the logs to the CloudWatch log, or you can S3 bucket. Let's click on the experiment template. Let's click on the create. And if we can see our EC2, so currently you can see that our two EC2 instances are running. So it will take a while. Okay, so you can see that whatever we have over there. So let's click on the start experiment. Okay, let's click here. Let's click on start, and you can see that our chaos engineering has been started. Okay, let's go here. Let's refresh it. Okay, you can see the action has been completed. Let's refresh this page. You can see that our one EC2 instances is getting shut down. And if we see our application as well, let's go K9MS. If our pod was scheduled on that node, so but currently it was scheduled on the 176. Okay, right? I think this was IP. No, this was the IP. You can see that our instance got terminated, and that pod was firstly was on that node. Okay, now the node was shifted on the new node, which is our 3.64 instance. So I think in this node it got scheduled, and horizontally you can see kubectl get node -o. Yeah, so these two nodes are here, and you can see this node is not ready. This node is not ready. Okay, so now what we have seen in this demo, that this demo we have seen that our one node got disrupted and our pod was running with the one pod. So always in your production environment or the PT environment, be ensure that node it should be distributed. It should be distributed among all the nodes. Okay, if you have the 5 nodes, your nodes and 5 nodes are like created on a different zone. Your application pod is also deployed on the every zone. Okay, so if one EC2 got down of the one zone, your application will not be affected. So in this way, chaos engineering can help you. So that's it. That's in today's video. And if you enjoy this video, and if you would like to see more like it, so please subscribe to my channel and give this video a like. Your supports helps me create more content. Okay, and if you have, feel free to post any question or topic you would like me to cover in the comments below. Thanks for watching, and I will see you in the next video.